you very much. So yeah, the C4 model. For those of you who are not familiar with the C4 model, it is a way to solve this problem. So historically, architecture diagrams have been very, very bad, like terribly bad. And I see these sorts of diagrams on my travels all the time. You might be thinking, well, why aren't people using UML? I've literally heard every possible excuse you can imagine for people not wanting to use UML. And of course, all of these things are basically myths and misconceptions. There's very little truth here. So I created the C4 model a while back. You can find more information about it at c4model.com. And C4 model is essentially, if you're going to use boxes and arrows to draw architecture diagrams, right, that's fine, but try to do so with some structure in mind and make sure any notation you use is self-describing. That's essentially the key principle behind the C4 model. There's a set of abstractions that sit behind C4, software systems, containers, components, and code. So that's our kind of base building blocks. And then the C4 model is actually named after a set of diagrams. So C4 is context, containers, components, and code. And it's 4 levels of diagrams, but that basically allows us to tell different stories to different audiences, some of who are technical, some who are non-technical. And the concept here is diagrams as maps. So I live in Jersey in the Channel Islands. If you do a Google map search for Jersey, you're going to get that picture. It kind of zooms straight in and shows you the internals of Jersey. That's great if you want to know where the airport is and how to get to the town, but sometimes it's too much information. So you want to be able to zoom out to get more context. On the flip side, you can zoom in and eventually drop into Google Street View, which is a one-to-one mapping with the real world when the photos were taken. And I want to do the same thing with software architecture diagrams. I want different levels of zoom that allow us to tell different stories to different audiences. If there are any Wardley mappers in the room, I know diagrams are graphs, but the analogy doesn't work. Right, graphs in Google Maps pictures, so apologies, but sorry, not sorry. So the top 2 levels of C4, the system context diagram. In order to draw a system context diagram, this is a set of questions that you need to ask and answer. So what's the thing we are describing? What's the scope of the thing we're describing? What features sit inside? What features sit outside? Who's using the system? What types of things they're doing? And what are these system integration points? Answer those questions and you can draw a system context diagram. So this is an example from a workshop. The red box here represents the thing that was being designed. A couple of different user types, roles, actors, personas, and a bunch of external system dependencies. So that's a good example of a hand-drawn C4 system context diagram. Now we can do the Google Maps pinch to zoom thing, drop down to level 2, we get to the container diagram. I know, unfortunate clash of naming, I'll get to that later. By container, I mean an application or a data store. So in order to draw a container diagram, it's a different set of questions. What are the major technology building blocks? What are the features and responsibilities of those things, and how do they communicate? To answer those questions, and you can draft up a container diagram. So now what we've done, we've zoomed into that red box, and we can see now that that system is made up of applications and data stores collaborating at runtime. So that's the quick C4 in a nutshell intro. So now to some myths and misconceptions and misuses. I've seen this pop up on the internet a few times. I've only just heard of C4, I guess it's new. Not really. I don't know when I created it, but it was somewhere around 2007-ish. So it's been around quite a while now. No. It's literally not changed since about 2007. So the only big addition to C4 was the addition of deployment views, deployment diagrams. But the actual core concepts of the C4 model and approach are basically the same as they were all those years ago. This is quite an interesting one. I think I saw this pop up on Reddit of all places recently. C4's been around for over a decade. If it was truly useful, shock horror, right? It would have replaced UML in most teams. Now this is interesting because it has replaced UML in most teams, but people were never using UML to start with. So that's one side of this equation. But the other side of the equation is that C4 actually wasn't designed to replace UML, which sounds weird. Why do I say this? Because I'm trying to bring structure to boxes and arrows diagrams. So C4 is really a set of abstractions and a set of diagram types. And of course, many of the teams who are adopting C4 have never used UML in the past. So really, this is them moving to a more structured way of drawing diagrams, a more structured way of working. I've seen tons of interest around C4 over the past, especially 5 years actually, kind of post-COVID. It turns out when people were working from home, organizations found it harder to get things done. Communication was more difficult because we were all behind Zoom calls and things like this. So I've seen many organizations, many of which are my clients, who have adopted C4 as their kind of standard preferred approach for diagramming across all of their teams. It's also being taught at a whole bunch of academic establishments, universities and colleges around the world. So I have a whole bunch who are using my tooling for free. And my C4 book is actually being used as course material for a bunch of other universities and stuff as well. People ask me, why did I reinvent UML? I didn't. C4 is this. It's a set of hierarchical abstractions, a set of hierarchical diagrams. It's notation independent, and it's tooling independent. So of course, given that C4 is notation independent, I can't be reinventing UML, because UML gives you, via its 800 pages of specification, all of that notational stuff. It turns out, and this is a slightly controversial, but it turns out that you can use C4 and UML side by side. So you take the C4 abstractions and the C4 diagram types, and you use the richness and semantics of the UML notation. So it's entirely possible to do that via the various extension mechanisms. I don't see people doing this for obvious reasons, but it's there if you want to. C4 defines 4 levels of abstractions, 4 levels of diagrams, but I really recommend people only use the top 2 levels. So this begs the question, well, why is it called C4? Why is it not called C2 or C3 plus other levels? And the answer is grounding, reality. So here are the abstractions from C4. We can go from the software system all the way down to the code and back up again. If I presented the top 2 levels only, what you've got now is 2 kind of abstract levels floating around a code base somehow. So for me, this gives me the transparency and traceability from the top to the bottom and back up again. So this is about reflecting reality, reducing that model code gap that George Fairbanks talks about. Notation. There's a bunch of misconceptions around notation. This one drives me bonkers. I see a bunch of stuff on the internet. People say the blue and gray notation of C4 is boring. Well, guess what, folks? It's notation independent. Other colors are available. So fun story for you. If you go to the C4 model website, you're going to get a bunch of example diagrams. And historically, all of those example diagrams have been the blue and gray boxes. If you go there today and refresh a bunch of times, you'll get different color versions of the same diagrams. Because I'm utterly fed up of people saying blue and gray looks boring. I'm like, thanks. In order to draw some example diagrams, I needed to choose some colors. I chose blue and gray. End of story. Don't read too much into it. One of the other things I see people say is C4 is unclear because it forces you to put lots of text in the boxes. So this isn't a C4 thing. This is really a bunch of notational tips surrounding C4. But I think actually the reverse is true. So here's an example diagram. This is fairly typical of what people draw. It's vague, it's ambiguous. So my recommendation here is add some more words. Add something about the responsibilities of the boxes, the types of data that are being stored. And I think this gives a nice at-a-glance view of what's going on here within this particular solution. The trade-off here is, yes, the diagrams do look quite cluttered. There's lots of text. But my recommendation is have this as your default. So have this as your default version in documentation, in presentations, et cetera, If you need a different version, if you need a simpler version for a presentation, just create a simpler version without all the text. Again, tooling can help here. Some tooling can just turn it on, turn it off. Other tooling, you have to copy paste the Visio file and change all the text in the boxes. On the same theme, I've seen a couple of people say this. We found the notation too cluttered, so we removed part of it, and they're normally talking about the metadata. What do I mean by the metadata? In my C4 diagrams, you'll see I add some text in square brackets. This is a container. This is a person. This is a software system. So I'm adding some metadata visually to say this is exactly the type of abstraction you can see on the diagram. I'm doing this because it removes ambiguity. And of course, when you remove that metadata, well, now it's not clear what's a container or what's a software system. So now it's very easy to misinterpret the diagram. So again, I'm a big fan of keeping that metadata wherever possible. Viewpoints. I get this a lot. This is quite a common one. C4 isn't good at showing decisions. is the correct answer. No, it's not. You're not supposed to show your decisions on architecture diagrams. Your architecture diagrams show the outcome of the whole decision-making process. Which begs the question, well, how do you record decisions? And the answer is architecture decision records. So there's a whole bunch of better ways to start recording decisions. And my advice would be keep these things separate from your diagrams, otherwise they become very, very cluttered, of course. If you can link these artifacts, then that's even better. People tell me that C4 omits the deployment story. So, partially true, I guess. C4 is named after the static structure diagrams, and the static structure diagrams do, on purpose, omit the deployment story. However, C4 itself, the whole concept around it, was inspired by UML and Philip Critchley's 4+1 model, both of which, of course, include deployment aspects. So therefore, if you go to the C4 model website, you will see some example deployment diagrams on there. And my view of a deployment diagram is we're showing instances of C4 concepts, so typically containers, but also could be software systems, mapped onto things in the deployment world, infrastructure. So you can draw deployment diagrams with C4 concepts, and you can also draw your typical cloud architecture diagrams with all the fancy icons if you want to. So that's all completely possible with C4. We don't need C4 because we do DDD instead. What? Like, this literally makes no sense, but I've heard a bunch of people say this. Ditto event modeling. Well, I've got nothing against DDD and I've got nothing against event modeling, but when I see things like this on the internet, it just, again, drives me crazy. It's like these people don't understand what they're saying. All of these things are complementary. They're showing orthogonal concerns. You could do your whole design process with DDD and event modeling, and that's going to show you some aspects of the system. Ultimately, you're going to have a bunch of things running on servers. That's what C4 is designed to show you. It's designed to show you the things on servers and the things inside those things on servers at the different levels of abstraction. Of course, C4 and time. Yeah, C4 again is about static structure diagrams, but there's nothing stopping you drawing something like a UML sequence diagram of how C4 concepts interact at runtime. So this is a sequence diagram of containers and components, and the diagram you'll see defined on the C4 website is called a dynamic diagram, and it's essentially modeled after the UML collaboration diagram. So it shows you the interaction of things at runtime, in this case, the sign-in feature for an internet banking system, and it's using numbered ordered arrows. So again, all of this stuff is completely possible. Right, so that's some of the more basic stuff. This is going to get more advanced as we go through. Abstractions and naming. I know the container is confusing, and I apologize, but I still don't have a better name. I did get the name first. I know that's completely irrelevant because Docker's a little bit more popular, which is sort of awkward. So if you want to rename the abstractions, you are more than welcome to rename the abstractions. I don't have any good suggestions. If you do want to rename the abstractions, please do not do that. So container becomes component, and component becomes subcomponent. This is really confusing, not just for me, but for other people who have adopted C4 already. In terms of naming abstractions, this has come up a couple of times in bigger organizations. So bigger organizations that have said, like, oh, we've adopted the Spotify model, and we have a bunch of tribes and squads who are now modifying shared code. And so when we draw a C4 diagram, the software system represents the squad. I'm like, what? That makes no sense at all. The software system should be the thing that multiple squads are changing. So again, there's a one-to-one mapping here with the thing that's being changed, not the squads. Bunch of misconceptions around C4 being too limiting, which I think is kind of interesting. So this popped up on this blog post. A database is a database. Debating whether it is also a container or a component just isn't worthwhile. So the wider context for that quote was further up or down in the same blog post. The problem is that systems today have many different kinds of things: servers, databases, virtualized containers, APIs, etc., etc. Forcing them into one of C4's 4 levels of abstraction doesn't really accomplish much. And I get what they're trying to say here. They're like, our systems are way more complicated. Why should we try and force things into just 4 levels of abstraction? What's wrong with having like 10 levels of abstraction or 5 levels of abstraction? The problem here is words. What is a database? A database is a database. That's what that blog post said. But what do we mean by database here? Are we talking about a database server or a database schema or a collection of tables? I don't know. It's a very ambiguous term, isn't it? So to put that word in context, you might hear people say microservices shouldn't share a database. I'm happy for multiple services to share a database server instance. I'm less happy for multiple microservices to share a single database schema. So I think we have to get a little bit more precise in the terminology that we're using here. And that's exactly what the whole is this a container or a component thing forces you to do. It forces you to think about, is this thing deployable, in which case it's a container, or is it something that sits inside a deployable thing, in which case it's a component. So I think actually, ironically, the power of C4 is not the diagrams. The diagrams are super useful because onboarding new developers is easier, communication is easier, you can do threat modeling on the diagrams. There's a bunch of good things you can do with the diagrams as an outcome. But the real power of C4 is not the diagrams, it's the set of abstractions. It's forcing you to have more precise, better conversations to better identify what the architectural building blocks are in the systems that we build. So that's my point of view. Others disagree. And you'll find a bunch of tooling out there that has, so I have a bunch of tooling called Sturcturizr that gives you a way to, as diagrams as code, basically draft up C4 diagrams. And it supports software systems, containers, components. There's a bunch of tooling out there that has taken this approach and kind of extended it and allows you to define models with arbitrary levels of abstraction. So the example here is like C4. And that's fine. I can see there might be some benefit of doing this. But this is the example from the like C4 website. So we're defining a model comprised of a service. It has 2 components, both of which have subcomponents. Well, they're not called subcomponents, they're also called components. So you notice we're using the word component here and multiple levels of abstraction. I'm confused again. This is exactly the problem I was trying to solve with C4 in the first place. What does component mean? If you look up the word component in UML, it means a modular unit with well-defined interfaces that is replaceable within its environment. Environment is many things here, isn't it? Component means part of something bigger. So this is the problem. If you do start to rename the C4 abstractions, if you do want to add more levels of abstraction, please make sure you give these things a well-defined, precise meaning. If there's any ambiguity in there, we basically get back to the mess we had before. And that's the thing. You know, if we go back in time, people drawing ad hoc boxes and arrows diagrams with no abstractions. I created C4 to define some abstractions that I thought were useful, and people have said, well, that's too limiting, we want more abstractions. And so what they think they've done is they've kind of taken C4 further to add the ability to have arbitrary levels of abstraction. The problem is this isn't a straight line, it's a circle. Because once you start adding additional levels of abstraction, you basically get back to the mess you had before if those additional levels of abstraction are not defined clearly. So that's my cautionary tale about that whole side of things. Abstraction versus organization. So I get a lot of people asking, what are my thoughts on modeling additional levels of abstraction and additional abstractions themselves? So what sort of abstractions are people wanting to define? Subsystem. So what's a subsystem? Well, it means part of a larger system. It's not a particularly well-defined term. I don't see it being used anymore. It's more of a term from like 20 plus years ago. The problem with subsystem is people ultimately want to draw diagrams like this. It's like, here's a software system. There's a customer thing and an order thing and a billing thing. I'm like, great, thanks. There's 3 million lines of code under here that's a complete mess, but this is what the subsystem diagram looks like, and it all looks beautiful and clean. I don't think this is a useful diagram, so I'd kind of advise against the whole subsystem thing. You see these things on architecture slides. Bounded context. This is going to upset some people, but I see the same thing happening with bounded context. Right? They're really just using bounded context as a way to kind of group stuff together into subsystems. And they use different shapes because DDD. But essentially we get like the same type of thing here. I apologize, I've probably upset a bunch of people now. So we'll move on from that. Layers, so architectural layers in particular. Imagine you have an app which has some web stuff, some controllers, some services, and some repositories, like a bog standard kind of layered architecture. I think it's fine, but what many people want to do is they want to draw that picture, which isn't useful. Now, I've drawn this type of picture myself in documentation, and in retrospect, it's just not useful. It doesn't really tell me anything. You may as well just write a bullet list of we have 3 layers, they're called these things, done. There's not much value having a diagram here. I mean, this diagram's probably lying to you anyway. There's probably a bunch of dependencies that are not shown here for clarity reasons. So the whole thing about architectural layers, I don't really consider them abstractions. I think architectural layers are really more organizational constructs. And I think that's the better way to approach some of these types of questions. So if I go back to my original diagram, I think what I want to do here is I want to say all of the service things live in the service layer, and I want to draw a boundary around those components in this case to say these things live in the service layer. Similarly at the bottom with the repository layer. So I'm using layers here as an organizational construct, not a specific level of abstraction. Once you start thinking like this, you can then, of course, say, well, actually, those things are coming from a specific jar file, and the things at the bottom are coming from a different jar file. So you can now superimpose things like jar files, deployment units, or modules on top of that same type of diagram. Message-driven architectures. This is one of the things that always gets people. The first time many people draw a message-driven architecture, they'll typically draw that. So service-based architecture, a bunch of services pushing messages into Kafka, a bunch of services pulling messages out of Kafka. This is true, it's factual, it's accurate. You know, most message-based architectures look like hub and spoke architectures when you draw them in this way. But I think this might be hiding the true story. Maybe the true story here is really that there's a point-to-point coupling between A and C and B and D via separate Kafka topics. So what I've done here, in the previous example, I'm trying to model the whole Kafka broker as a C4 container. I don't think that's the correct approach. I think the correct approach is to model the individual topics as C4 containers. What is a C4 container? It's an application or a data store. A topic is a data store. It's a bucket. We put stuff in and pull stuff out. We can deploy these buckets, these topics, onto a single broker or multiple brokers. So I think this makes sense from the kind of C4 perspective. You notice all the arrows go left to right. You can also reverse the arrows and change the text. And I think that still makes sense. So I think this approach is better for showing point-to-point coupling, and this approach is potentially better for pub-sub relationships, especially when you have one to many, because you can show that Kafka topic as the thing that provides the many. You could also, in P2P examples, do that. You could just draw a line between the two containers or components and say via Kafka topic X. So this is telling like the same story. It's visually simpler, but the Kafka topic is now a bit more hidden. It's a bit more implied, a bit more implicit. Some people like this for its visual simplicity. Others prefer the more explicit version. It's all trade-offs. Choose one, see if it works. Shared libraries. Shared libraries also throws people. So imagine we have 2 apps, and there's a shared logging component. So we've got a bunch of shared code in a shared library, a shared jar file, a shared DLL, and we're using that code from both apps. It's very tempting to draw that type of diagram where we are representing the shared library as a C4 container. This is generally not true. So in this diagram, it looks like the shared library is an application in its own right, and we're broadcasting logging things to that application via some inter-process communication link. I don't think that's the true thing. What we're really doing in most cases is we're copy and pasting that logging component into both applications. So I think this diagram is a better representation of that concept in action. So now we can see the logging component is actually appearing twice, once in each component diagram. If you want to kind of highlight that this is a shared component, you can do that through notation. So here I've said the shared components are gray, and of course I include that in my diagram key. So there's a bunch of different ways you can think about shared components. If you want to bring back the module concept, the shared library concept, you can just do the same thing as before. You know, just treat that shared library, that boundary, that module as an organizational construct. If you had other shared components also coming from that shared library, that would be a great way to also show those concepts. Micro frontends is a bit of a can of worms. If anyone is doing micro frontends and they're struggling from a C4 perspective, go and look at the page on Martin Fowler's website by Cam Jackson, and specifically take note of the integration approach. So is this a bundle of JavaScript code that you are including in your web page, or is this an iframe embed? I think the integration approach will drive you down the right route. So is this micro front end some containers, or is it really just a bunch of components? I think for most of the integration approaches, it's really just components that are included inside the application. This is the fun one, microservices. This is the one that a lot of people kind of get wrong. So first of all, before we get into how do I do microservices, this quote appeared in a book. C4 is more suited to monolithic architectures and doesn't support distributed architectures as well. I have been told that this quote is coming out of the second edition of the book. I know who wrote this. I'm not going to tell you who wrote it. The reason this is written in the book is nothing to do with the capabilities of C4. It's really one of scale. So the underlying message here is the C4 diagrams don't scale well when you have lots of distributed things. I'm going to bust that myth in a second as well. So let's go back to microservices. I see some people saying this. We're modeling microservices as containers with APIs and database schemas as components inside those containers. That's the wrong way to do this. So a C4 container as a separately deployable thing, a C4 component is not individually deployable, but we have APIs and database schemas which are deployable things being modeled as components which are not deployable things. So there's a mismatch. What's happened here is somebody's dropped down too many levels of abstraction and now they're kind of stuck. So how do you model microservices? It depends. I think microservices should either be modeled as one of the following three things: a software system, a container, or a grouping of containers. Now, this advice doesn't sound useful yet, but bear with me for a second. So let's backtrack. What is a microservice? Right, we have to answer the what is a microservice question in order to properly answer how do we model microservices. So let me do this through an example. Imagine we work for a startup, we've got no money, and we've been asked to build a system that does a bunch of stuff. So here is our system context diagram for the thing we are building as a startup. We've got some users, and we're providing a software system, and it's providing a bunch of business capabilities. When we zoom into the system boundary, because we're a startup, we're going to build this thing as a monolithic web application talking to a monolithic database schema. So that's the container diagram, showing the web app and the database schema. Right, so that's easy, no problems at all. Now we've got some more users, we've got some more value coming in, we've got some more money coming in. Now we can jump to microservices. We've got James Lewis in and Sam Newman in, and we've gone through the training, and we're all in a happy place, and we know what microservices are. So what is a microservice? So let's go to the page on Martin Fowler's website, James Lewis. In short, the microservice architectural style is an approach to developing a single application as a suite of small services, each running, et cetera, et cetera. I think this is a great definition. There's one change I'm going to make, and I'm going to replace application with software system to bring this back to C4 terminology. So imagine we've now switched from a monolith to a set of microservices. Our context diagram remains the same. We have a user, we have a system, the system is providing a bunch of capabilities, that's the same. When we zoom into the container diagram, I'm going to say that's now what it looks like. So now what we've done is we've converted that monolithic web application and database schema into one service for capabilities A, B, and C respectively. Each service is made up of an API thing and a database schema here. Now I've used color coding, so you can very clearly see there are three services. So each service is a pair of elements. If you want to more explicitly say what the service boundaries are, again, think about using organizational constructs. So here I'm drawing a line, a boundary around the API and the database schema pair and saying this pair represents a service. This thing represents a microservice. So I think this is fine. As a single team building a set of microservices, I think this is the right approach. So this is the model your microservices as a group of containers. So we've ticked one of those options off now. If you have a microservice that is just one thing, so imagine we add capability D to our software system, and we're going to build it with an AWS Lambda written in Python, but there's no data, it's completely stateless, it's a complete stateless service. Now we're representing the microservices as a group of containers, and also as a container itself, because it's only one thing. So that's another option ticked off. All good so far. Now imagine we got loads of money coming in, and we're scaling really quickly, and we're becoming a big enterprise. And now we're going to do the Conway's Law thing. So at the moment, it's one team building everything, but now we're going to do Conway's Law. We're going to have different teams owning different services. The world's going to be a happy place, lots more integration, lots more growth. This is now our context diagram. So what I've done here is I've said, right, we as a team are still going to build the application, the web app, but all of the services are going to be farmed out to separate teams that we are now spinning up to take advantage of Conway's Law, et cetera, et cetera. So we have a team for service A, service B, service C, service D. So my context diagram is now different. My container diagram for software system X is also now different. So we have the web application, so we're still keeping the monolithic front end, but now we're treating those services as separate software systems. Another box ticked. So in this example, we are treating the services as software systems. I, as a member of Team X, now no longer care about the internal implementation details of all of those services. They're owned by different teams. I can't see the code anymore. I'm just using the API. I have a dependency. That's what my context and container diagrams show. So really, whether you treat microservices as containers or software systems depends on who's owning them and whether you can see the internal implementation details or not. If this organization was behaving themselves and being good documentation citizens, they would draw a bunch of diagrams for each of the services. So this is the context diagram for service A. So it focuses on service A and shows our system X as an inbound dependency. And when we zoom into the container diagram, we get what we had before. So service A is made up of an API thing and a database schema, and both those things are within the system boundary. So that's microservices, and I think it's relatively straightforward. We still have the scaling thing. We still have the C4 is not really suited for showing lots and lots of things. So how do you use C4 at scale? Imagine we have a bigger service-based architecture. In this case, we have 8 services, again, and there's a monolithic web app at the top of it. So same thing, every service here is a combination of an API thing and a database schema thing. Rather than draw one diagram showing 8 services, we could draw 8 diagrams focusing on one service each. And of course, this would allow us to scale much better. Every time we add a new service, we can add a new diagram. Tooling can help or hinder you here. So with a tool like Visio, you have to now start copying and pasting things across multiple tabs, across multiple worksheets, and it just becomes really awkward. With my Sturcturizr tooling, which is models as code, and an emphasis on models here, not diagrams, it's very easy to draft up a bit of text that basically says, create me a container diagram for the software system, include the user, include service 1, include its inbound dependencies, the inbound dependencies and the outbound dependencies. So the afferent and the efferent couplings. And we get that picture created for us by the tooling. And then we can say, do the same for service 2. And it's literally just the same. It's a small bunch of text. The code behind this analyzes the model, because we are building a model here, and it's doing the same thing. Ditto for service 3. So this is a really nice way, again, tooling independent, this is a really nice way to slice and dice the model and to give you multiple views on that same model. So that's option 1 about dealing with scale. And of course, you can apply this to containers or components, entirely relevant. The trade-off here with this option is you're now missing the bigger picture. We've zoomed in, and we're taking a small partition view of the world, one step at a time, and we miss the bigger picture. So option 2 here is to use the same concepts and to create a C4 container view, but use a different visualization. So here we've moved away from like the static boxes and lines diagrams, and this is interactive, it's dynamic. This is a D3.js force-directed graph, so you can move things around by clicking and dragging. And this shows you the same information in a much more condensed, concise visualization format. We can click on things to show nearest neighbors. This is super useful for exploring a collection of services, a collection of software systems in an application landscape, in a system landscape, or a bunch of components in a monolith. There's tooltips you can add additional metadata. So there's a bunch of interesting things you can do. When you consider this to be a set of data structures, it's a graph, and we can slice and dice the graph essentially. Option 3 is you take this same data and you stick it in yet another tool. So there's a great tool called IDAgraph, and this is an export of that same set of containers and their relationships. And again, this is nice. This is a bunch of static screenshots. But what we have here is a nice interactive UI where we can click around things, zoom in, zoom out, show nearest neighbors. So again, we can do the same sort of thing. So this is why I'm a big fan of the whole kind of models as code approach. We craft up a model of our software architecture at multiple levels of abstraction, and then we can do stuff with it. We're software developers. We can write code. We can do a whole bunch of interesting things. We can ram this stuff into a Neo4j database and write Cypher queries to find out what dependencies are. We can do static analysis and build our model automatically from scraping information out of our code base, or scraping our AWS configuration, for example. So there's a whole bunch of really interesting stuff you can do if you consider this is really views onto a bunch of data. Dependencies to external containers. So when I'm drawing a container diagram, I'm generally recommending just focus on a single software system and show the containers inside that software system. So if I'm building a system called A, and my system is made up of a Spring Boot application talking to a system you folks are building called B, this is my container diagram. I'm showing you the app in my system boundary with a dependency on your software system. This is my recommendation. From your perspective, if you are drawing a C4 diagram of your system B, that's your container diagram. So inside there, you might have a Node.js API container, and that's the thing receiving inbound requests from my software system called A. So I think this is the recommended approach. From my perspective, I can see my containers but not yours, and the reverse is true. So I don't recommend showing external containers. What do I mean by this? What I mean by this is drawing that diagram, where we see there is a container in system A talking to a specific container in system B. If you are one team and you're building both, I might let you get away with this. If you are multiple teams and you know that you're calling something else in someone else's system and that's a diagram you want to draw, I would kind of say, no, don't do that. Why? It shows me that you know the internal implementation details of someone else's system, which makes your diagrams volatile, and it's a form of coupling. I'm coupled to the information. When I see this, I often question the team boundaries. Perhaps those two teams really should be one team. So there's some interesting feedback loops here, potentially. As with everything, there are always some exceptions to the rule. Shared databases. I know we're not supposed to do this anymore, but historically we've typically integrated systems via like a shared database schema. So in that example, if my application was storing information or reading information from a shared database schema, and so was your system, I think we model that shared database schema as being in its own system boundary, and we want to show that specific coupling. Because this is a smell, it's an anti-pattern, and really this is something we want to refactor and move away from. So this is one of the few examples where I think showing multiple external containers actually makes some sense, because it's highlighting that there is an issue here. So those are pretty much all of the myths, misconceptions, misuses I generally have seen. The takeaway from the whole thing is remember, this is what C4 is. It's a set of hierarchical abstractions, software systems, containers, components, and code. It's a set of hierarchical diagrams, system context, containers, components, and code. It's notation independent, so blue and gray is boring, but other colors are available. And it's also tooling independent, and there's a whole bunch of tooling you'll find now listed on the C4 model website. So thank you very much, and happy to take any questions.